So, as we all know, this is one of the ocean series run by Aquaworld. And today we are going to talk about a very fascinating topic, which is iron from the desert, life in the ocean. Can I just double check that you all can hear me just now? Can you all hear me?
Yes, I can.
Very good. Yeah, just wanted to be sure. So yes, as I said earlier, our topic today is very unique and interesting. Iron from the desert, life in the ocean. And this topic is interesting because we could think desert and the ocean, how do they interact? I'm happy to let you know that today we are going to find out. But just a brief of introduction, we know that the dust from the desert blows over the ocean through the wind. So that's just a tip of the iceberg. So today we are going to dive deep into this interaction and see what we can learn from it. Today we're having a guest speaker in person of Mr. Segun Bamidele. He happens to be very conversant in the ocean. He has a degree from the University of Bristol in the environmental field as well. So I will invite him to kickstart the discussion. I don't know if you have your slide ready as well. It would be nice if you can share that. Can we all see the screen, please?
Can I comment?
Yeah, I can see it from my hand. Thank you so much.
Good evening, everyone. Thank you, Mr. Solomon, for that wonderful introduction. Just to correct something, my degree at the University of Bristol is still pending, so I'm still working on my dissertation. But yeah, I hope to finish soon and get the degree. So yeah, thank you very much for that introduction. So yeah, I'll be presenting on something very interesting. That's for something else. Okay, so yeah, so this is a very interesting topic. So can stop the, don't mind my title. So let me just take off this. So I'll be presenting on a very interesting topic, and it has to do with iron from the desert and how does it influence the ocean. And it's a kind of very interesting topic. It's something you wouldn't have been able to think of, or should I say, predict. But yeah, it's funny. I mean, and that is the one good thing with research, you get to just realize the connection between certain things that should not even be related. How should the desert be so influential to the extent that it can affect biological activities in the ocean, and that this could even be a source of geoengineered solution to climate change. So that is going to be something we are going to be looking at. So by the left of my screen is hello. Yeah. So by the left of my screen is desert storm, and by the right is the West African coast. So this is the West African coast somewhere, and this is the Atlantic Ocean. And as you can see here, you can see some phytoplankton bloom. So how do they relate? Basically, that is what we want to do. So first, I will start with this quote, and this quote was made by a scientific researcher named John Martin in 1988. He made this quote at a conference, and he said, "Give me a half tanker of iron, and I'll give you an ice age." I mean, this looks kind of abstract. What does iron and ice age has to do together? So we know that the Earth is warming, temperature is rising. We are 1.5 degrees Celsius above the pre-industrial level, so on. And somebody is now saying, if you give me a tanker of iron, I'll give you an ice age. So it's not even saying I will reverse the warming back to pre-industrial level, saying we will go back to the ice age, basically, like there will be a sort of snowball on the Earth. So how are you making sense? So that's what we want to check. Is it correct or is just exaggerating? So that's what we want to know. The first question, I don't know, can you see this? I don't know if this you are sharing your screen stuff is obstructing this. So basically, where do you think the world's largest dust source is from? So you have this list of options, and I'm interested in everyone's response. So just guess. What do you guys think the answer would be? So you can put your responses in the should I say comment box? Yeah, I was trying to create a mentee, whatever, but I couldn't create that. So you can put your responses in the comment box and just let's start with this first. I'm trying to follow. Okay. All right. So let me go back to my screen. I hope I have not. The answer is not here yet, thankfully. So just guess what you think the answer could be. Would it be the Sahara Desert, the Arabian Desert, the Dubai Desert, or the Australian Desert? All of these are like desert areas. So they have a lot of sand, they have a lot of dust, and we want to know which one of them produces the largest dust source in the world.
Sorry to interrupt, Mr. Segun.
Yeah.
I could see a couple of comments on the chat already. So a lot of people are saying that it is A, like Sahara Desert. And also, is there a way you could change your audio? It seems to not be audible for somebody.
Okay, so let me just give me a minute. Let me change it to my natural.
Yeah, that would be better because yeah, there's a lot of background noise just now. Thank you. Yeah, we can still keep answering the question. What do you think is the world's largest dust source? So the option A is the Sahara Desert, the B is the Arabian Desert, the C is Gobi Desert, or the Australian Outback. So please, if you want to give it a try, quite happy to put your answer in the chat box, please. Thank you.
Hello, is it better now? I'm trying to connect.
Yes, it is so much better now. Thank you. Now we just need it to yeah, very good. Thank you. You can take over from here now. We've had a couple of comments, so it's still the Sahara Desert that everybody's choosing just now. Yeah.
Okay. Okay, so I just want to confirm, can you audible?
Yes, you are audible very well now. Thank you so much.
So just give me a minute, please. I need to sort out my audio. I can't hear you guys.
Right.
I'm the one that can't hear you, so I want to like sort this. All right, so great. So the correct answer is the Sahara Desert. So if you have chosen the Sahara Desert, I'm happy to say it yes correctly. And I think some people would have really guessed this because it's quite popular. Like when you talk about deserts around the world, one of the most commonly mentioned deserts is either the Sahara Desert or the Arabian Desert, either of these two. So this one are like probably you are just getting to know the desert, Dubai Desert, and the Australian outback out there. But yeah, the Sahara Desert is actually the world's largest dust source. And for context, it contributes okay, I'm coming. What is happening to my screen? No, don't worry. Is it my laptop that? Oh, sorry. I think my laptop hung or something. So many things to get into it.
Yeah, no worries. Take your time. You can still see your screen anyway.
Yeah, I think my laptop for whatever reason of all time started to and I can't just move anything right now. That's great. So just give me another minute. Please. I'm sure. That's actually. Oh yeah, finally. So this is what I wanted to show. So this is like a pictogram representing how this interaction occur. So to the left, don't mind my infographic generally, but I just need to make this part stand. So to the left is this Bamidele depression. It's in Chad, and Chad is in Central Africa. And then Central Africa, Chad generally borders, I think Libya, yes, Libya, and Libya borders Egypt. So basically, all these countries they have the Sahara Desert in their country. So you have this Bamidele depression is a part of the Sahara Desert. So this just from these parts, because Chad is closest country to the Atlantic Ocean, of all the Sahara countries. Yeah, I use those Sahara countries because that's what they used to group the North Africans. So of all the Saharan countries, that is the closest to the Atlantic Ocean because it borders Nigeria. So this dust, it when winds blow, maybe through thunderstorms or whatever, so it comes to the West African coast, yeah, and then from there gets into the ocean, and then there are some sort of phytoplankton activities. Then you wonder, okay, what do phytoplankton to how will I put it, to build themselves? So it's generally nutrients in the dust. It's funny, but yeah, there are metal, heavy metals and the micrometals as well in dust samples, and that was that iron is one of them. And for those who studied is it plant physiology, originally, you know that we have what we call micronutrients and macronutrients. I don't know which one of the group iron belongs to, whether it is micro or macro. You know that plants needs iron. And when we talk about plants, not just the terrestrial plant, but even the aquatic plant. So the iron in these dust samples, when this dust gets into the ocean, there's some sort of solubility. So phytoplanktons are able to get the soluble form of this iron, and then they use it to, as part of the so they use it as part of the nutrients needed to grow. And then as soon as the organic matter and the biochemical activities in the ocean increases, you then see that these plants, they play an active role in absorbing carbon in the atmosphere. Yeah, the earth has warmed, there's greenhouse gases, there's a whole lot of stuff, and we are trying to look at ways to control these emissions. So all this, don't use fossil fuel energy sources, don't use cars that are being, driven by fuel, all this kind of stuff are just, we call those ones mitigation measures, but they are more like measures for just trying to reduce subsequent emissions. But we're not talking of what can we now do to take off the ones that are already in the atmosphere, basically. What kind of stuff? And that is why you see scientists or some people arguing that plant more trees, nature-based solutions, all this kind of stuff, because we believe that these plants, they play a key role in absorbing these greenhouse gases from the atmosphere. But what many people don't know is the role aquatic plants also play. So when you have phytoplankton bloom and you have dissolved organic matter in the atmosphere, in the ocean, they make use of oxygen, dissolve oxygen, and but most importantly, it also absorb atmospheric. So you can realize that the dust in the ocean, in the desert rather, influences activities in the ocean, which then influence activities in the atmosphere. That sounds like something you wanted to have thought of. So the key fact here is that this dust delivers, that is the Sahara Desert dust now, it delivers 56% of the iron fueling North Atlantic marine productivity. So basically, all the marine productivity in the North Atlantic, the iron that fuels 50%, 56% of it comes from the Sahara Desert. So it tells you that how important this desert, the dust from this desert is. So if it is single-handedly delivering 56% of the iron that is fueling marine productivity in the North Atlantic, then it's kind of very important. So what is then in this iron? I've already given you an insight into what is there, but let's just, so you will find out that you have in iron minerals, you have what we call the hematites and the magnetite. I think together they make up the what is the scientific name of iron? Ferrous or something, whatever they call it. Yes, ferrous. So the hematites, like for those in life sciences, yeah, it's one of those parts needed in blood, and that is why you find out that when you look at some of the blood tonic, they have to be iron or hemoglobin or but better still, your blood generally must be rich in iron. Yeah, it must be rich in iron. If your blood is low in iron, it's cause for concern. So I think the hematites is the one that plays that role. And then there's the magnetites, which is like the part of iron that makes it, that gives it the metallic properties. What makes it an healthy metal, like the healthy metal part of the iron. But that is not what we are talking about. So what was
Mr. Brian, please. Can you mute your mic, please?
okay? So yeah, what we want to look at is the okay. So can I continue?
Yeah, I think you can continue, but I'm trying to get Mr. Brian to mute his mic just now.
Okay. Okay, so let me just continue so I don't take much of our time.
Thank you.
Yeah. So as I was saying, so what we are looking at is the solubility of iron itself. So it happens that in dust samples, it has a solubility of 1 to 2% in the ocean. But in artificial fertilizers, it has a solubility of 15 to 20%. So you might want to wonder, in dust, it's 1 to 2%, but in fertilizers it is 15 to 20%. And the actual reason is because I think in fertilizers, a lot of fertilizers, I would say most, comes in aqueous form, or some people say liquid form. Basically, they are either liquid or almost semi-liquid. So every form of chemicals that have been added are already made to be soluble, but dust is still in the solid form or powdered form. So when they get into the ocean, they are still 1 to 2% soluble, but never mind, it's still in the perfect form to be taken by phytoplanktons. Now, when you look at artificial fertilizers, on the other hand, 50 to 20% solubility, it means when you apply artificial fertilizers, even on your farm, and then it gets washed away into the ocean, which some of you want to ask, then you find out there's rapid bloom of organic matter in the ocean, and sometimes it's not even good. I mean, in any water body, actually, as much as we want aquatic plants to thrive, we also have unwanted aquatic plants. So when there's the water is rich, there's eutrophication, and then that becomes a problem. And I think that is one of the questions somebody might want to ask. Okay, if you keep encouraging iron in the ocean, what about eutrophication? We will probably deal with that later in the question and answer segments. Okay, so next. Okay, so another question I want to ask is this. So what percentage of the earth comes from marine phytoplankton? I mean, the earth oxygen. We don't know that, okay, marine phytoplankton play a key role in removing atmospheric carbon from the
atmosphere, and like every plant, both terrestrial or aquatic, they also help in releasing oxygen. But what percentage of the Earth's oxygen actually comes from marine phytoplankton? I mean, we know plants help us gain oxygen, but most times people just think of terrestrial plants. You think of the trees, you think of the shrubs, you think of the grasses. So for marine phytoplankton, which is often overlooked, some people don't even know it in the ocean. So what percentage of the Earth's oxygen actually comes from it? So, let's just choose some answers here as well. Just put your answers in the comment box. I will be checking. Can you all hear me? I've asked the question and I'm just giving some minutes for everyone to drop their answers before giving you guys the correct one. Okay, someone said 80%. Okay. Yeah. Someone said B. Okay. Okay. So 80%. Okay. So let's not let me go back to my slide so we don't end up taking so much time. Yeah. So for those who were able to attempt it, you are correct, 50 to 80%. But I just want you guys to note something, and that is the fact that it's still subjective. Like we don't know the actual. So let me say consensus on the actual percentage. So that's why you have this 50 to 80%. It's kind of still ambiguous. That's the uncertainty level or the confidence interval is too high. 50 to 80%, it could be 65, it could be, so it's too high, but yeah, that's because we have not reached a consensus yet. But no less than 50 and not more than 80. That just shows it's very important. So that means the least contribution is at least half of the Earth's oxygen. That is the least. And it could go as high as 80%, which is the majority. So it's not 30%, it's not 90%, it's not 10 to 25%. So this just tells you how important marine phytoplankton are. Okay, so let me to the next. Oh, sorry. I think I get why I find it difficult to just give me a minute, please.
No worries, Mr. Segun. Thank you.
Yeah, I'm trying
said-
to move my paper. I think I'm on the Zoom. I'm on the Zoom video or something, so I need to go back to my paper. My laptop is just, I don't know why your phone is doing this way.
Take your time.
Okay, is there someone there with a copy of the slides that could just help me just move to the next? My laptop is.
Mm. I will need to.
Okay, finally. It's okay.
It's fine.
So the next thing I want to check is the biodiversity and climate impacts of iron generally. So first image I will show you here is an experiment I ran by myself, and that's why I'm generating this image on my own. So there's this model, we call it the C-Genie model. It's a carbon gridded out model like that. So basically it allows you to simulate some atmospheric or oceanic condition from computer and try to like understand what you think the world or the earth will look like in certain period of time. Probably, for example, I can decide to say, okay, if I increase the atmospheric carbon level between now and let's say in the next 50 years, I want to know what the impact will be towards the end of the 21st century. So it simulates them. It has been built based on the physics of our current time. And then it gives you that idea. It's also what scientists sometimes use to understand what has happened 300 years ago, 200 years ago. A whole lot of stuff that has happened long before we are born. So those are not, that's what the CGNE model does. So what I have done is, now you can see something here. When you can see something around this place. Yeah, what I have done is I have injected iron, like dust. So what I did was, on that computer model, I thought to myself, okay, supposing I had so and so flux of dust every year between now and the next 75 years, what is the implication? Now, ideally, West African coast is low in nutrients, particularly iron. It is very low. It is not rich. The parts that are rich at this part of the world, I didn't interfere with them. So naturally, you can see that those parts of the world are on their own. They're just okay. Like, they already have iron. You can see it here as well. However, this part of the world, the West African coast, I was one who added iron, and that is why they look kind of. You can tell that this is something that somebody added or messed up with. It's not natural. So, but what I wanted to do was, I want to understand if I inject iron in this part of the West African coast, like, and iron is coming from the Bamidele dust. What? Yeah, from the Sahara Desert or from the Bamidele depression. So, what impact does it have towards the general oceanic life and other continents of the world? So, another image I would like to show you is this. Okay, great. Is this image I have here? So in this image, you can see this one is the dissolved organic matter as a result of this iron injection. And looking at this image, another thing I just want us to take note of is the fact that this image, you can find this organic matter here. You can find a little here. And when you look at them, you can tell that it's because of this iron that has been injected in. In this part of the world, this was iron before, but the organic matter content there is low. You can find this here. You can also find this here. Like, basically, they correspond to the presence of a particular nutrient. So if you have a nutrient in this part, in one part of the world, how does it influence biodiversity or organic matter production? But where I'm going now is, you can see the sort of movement. The iron I injected here was a little bit constrained here. But when you look at the organic matter here, you can see that the sort of movement, it's coming towards the South American continent. And this is why scientists have come out to tell us that the Bamidele depression dust itself is also responsible for biodiversity in the Amazon forest in Brazil. If you are familiar with biodiversity many talks, we all know that the Amazon forest itself is a very important forest globally, because it's also world's oxygen. So you can see the connection between dust, iron, phytoplankton bloom, and oxygen. So this one, they're telling us that the might contribute 50 to 80% of oxygen. So you are seeing the connection now. It is because the marine phytoplankton here, due to iron injection, get to South America, and then they contribute to the Amazon rainforest, which has been said to be the world's largest contributor to oxygen among the terrestrial rainforest. So that is the relationship between this. Okay, so let's move on to the next. Okay, I'm back here again. I don't want to be here. Okay, so
Mr.
here
Segun,
is like I'm at.
it seems your screen is paused just now, so we can't see it currently.
Oh, no. Okay, let me
You post screen sharing.
Let me resume it again.
Yeah, it's back
Can you
now.
see it now?
Yes, thank you.
Okay. Yeah. All right. So continuation. So this is like another infographic that tries to summarize all of this. What we have been saying all this while is that I'm trying to remove this so that I don't know if it works. So all we have been saying so far is you have they come into the ocean. Once they get into the ocean, you have this sort of phytoplankton bloom. As a result of photosynthesis, then you have sinking organic matter. Then the more this phytoplankton, the more foods are available for marine life, like fish, octopus, the crabs, they feed on some of these phytoplanktons. But most important, actually, apart from the fact that it helps to it improves productivity, aquatic productivity. It's also the fact that it also helps to remove carbon dioxide in that. A summary of what we have been saying. The dust from the desert into the ocean, then once they get into the ocean, they introduce iron. Due to the iron, there's a phytoplankton bloom. As a result of phytoplankton bloom, the aquatic lives like fishes, the prawns, they have enough phytoplankton to feed them. But apart from this, the phytoplankton themselves, due to photosynthesis and all, they release oxygen and then they help us trap or take out carbon dioxide from the atmosphere. So these are like the summary of what I was saying. So just before I round up, yeah, there's some ethical concerns because this is like a geo-engineer solution some scientists have been trying to like encourage that, okay, look, we've messed up with the world, there's climate change, say plant more trees, plant this, plant that, but we can actually introduce iron into the ocean to accelerate atmospheric CO2 removal. And they're like, what? No, some people, it sounds crazy because that is you trying to interfere with nature sometimes. Like, okay, why we go and pour iron or dust generally into the ocean? Like, you are trying to mess up with the ocean biology or chemistry or whatever food webs that have been created. So that has been some sort of argument. And there's still more research being done to be able to say, we want to convince you guys that this is one of the ways to mitigate climate change. And the fear has always been that, okay, in our quest to mitigate or reverse some of the anthropogenic climate change we are responsible for, are we not going to probably, introduce another problem? So that has been the current debates. So yeah, it looks like a feasible solution, but more research is still being done until we are perfectly sure that this is going to be one of those things we can do to, mitigate climate change. Okay, so
Thank you, Mr. Segun. Do you still have any other addition to make concerning?
Not really. I think this is the last slide. I was trying to go to the next one.
Oh, very good. Yeah, that was really insightful. That was a lot of information to take in for every one of us. And I'm sure we must have learned one thing. For me, I really learned that it's quite interesting to know that iron is one of the micronutrients that is very essential for phytoplankton in the marine life. And then that in turn makes the importance of oxygen a key factor in this effect, in this interaction. So that's really, really helpful for us to know. I don't know if anybody have question that they might want to ask our guest speaker today. Myself, I have a couple of questions. Maybe I will start with mine first, while we wait for others to come up with their question. So for me, it's quite interesting to see this interaction, but I'm curious to know how climate change connect with this interaction of the desert dust with the ocean? How does climate change, what impact will climate change have on this interaction?
Okay, so how does climate change come in?
Yeah.
Okay, yeah, great. So climate change, so when we talk about climate change, what many people think of, which is also correct, is the earth has warmed, and that is like the shift from the aspect of temperature increase. Some also argue the rapid occurrence of extreme flooding event and the like. But also, what people also tend to, like at least at the old level knowledge, is that there are increased greenhouse gases in the atmosphere. So, and CO2 happens to be one of these gas, like one of the greenhouse gases. So, like I said previously, one of the things phytoplankton do for us is they provide oxygen. And in the process of providing oxygen, they take in carbon dioxide. It's just like the green plants in the terrestrial habitat. So for everything that can take or help us reduce these greenhouse gases in the atmosphere, then they're helping us reduce or reverse the effects of greenhouse gases on the ozone layer and generally climate change. So basically, if the dust from planting needs as essential nutrients, and from these nutrients, their productivity is increased, they help us provide more oxygen, and because their productivity is also increased, it also means they tend to use a lot of carbon dioxide in the atmosphere. Then it is a good source of climate change mitigation. So that is how climate change comes in as well.
Yeah, that's quite explanatory. Yeah, thank you for sharing that. So indeed, if actions is not taken concerning the effect of climate change, maybe we could end up with what you suggested earlier, that people are considering of adding iron into the ocean, if that would help. So maybe that would be like an extreme situation that we might end up in if things get worse when it comes to climate change. That was really insightful. I don't know if anybody has a question. You could unmute yourself and ask your question. I'm even wondering as well, has anybody ever seen these dust storms, or have anybody ever heard of the ocean fertilization before? I mean, I'm not sure anybody has been to the Sahara Desert to witness this, or maybe probably in videos or in movies. Have you ever seen it before? Oh yeah, somebody just commented that there was a dust storm in Sokoto on 22nd of June. That's from Mr. Mohammed Obari. So that gives us like a glimpse of what really happened of this interaction. Yeah,
Okay, I think
yeah,
someone asked the question, is there a
okay.
negative effect of so much desert in the ocean? Like it is one of the ethical concern that scientists are trying to argue, like, okay, we know that we can, under control conditions or under little conditions, we can add, in fact, if we allow it to play out naturally, without human, it is only when human interfere with nature we spoil up things. So if we allow the dust to play out naturally, no effect, like it's fine. We've never had period. But if we start introducing into ourselves, like you said, so we could add too much, and yes, there's going to be a problem. Now the problem is, firstly, although the ocean is very wide, it's very big, it's about 30%, but like everything in life, there's always going to be a limit to what can be added and what can be added. And the fact that we're trying to engineer a form of ion injection into the ocean, there's no that means you go and carry like a tipper of dust, for example, now, and just pour it on one part of the ocean, just one part. Like you have to at least spread it so that there's some sort of solubility. That's why I show you a part from the beginning that the solubility also matters. So you don't want to add too much concentration of dust or ion in one part where they find it difficult to become soluble, and then they become counterproductive. So having too much of desert dust in the ocean can be a problem. But that is when anthropogenic influence comes in. If you allow it play out naturally, no problem. We have never had problem up to this moment, but
Yeah.
if we are the one that now want to control this thing, then there could be problem.
Yeah. So having the natural action play out is so much more better than
Yes, and that is the ethical concept. Of course, like you said, maybe if whatever aim we are trying to achieve, like 2050 or whatever year we are, zero is, if it's not working, maybe out of desperation, I don't know, mankind, we are very funny. We may not decide to start injecting into ourselves, but for now, the belief is let it play out, right?
Yeah. Thank you for sharing that.
We just now know that this desert storm that happened play a good role in helping. So just let it keep playing out by itself.
Yeah, very good. So we have a follow-up question from Mr. Deyinka. The question goes thus: that your comment was wonderfully explained, but what are the prospects if we leave things to play out naturally? So the person is wanting to know what will be the changes in the next 10 years.
Yeah, thank you very much for that wonderful question. You see, let's be honest with ourselves. Like we said, climate change. Supposing we leave things out naturally. In fact, my professor will always say something. Don't use climate change. Use the word anthropogenic climate change. And why do we use the word anthropogenic climate change? Because we're not talking of the climate change that is due to human activity. It is always human that are it is with the humans that are the problem. Supposing we allow things play out naturally, I'm telling you that even desert dust, the terrestrial plants we have alone, like supposing for whatever reason we stop emitting greenhouse gases, we'll see change in the next 5 years. Actually, the only reason there's been a sort of balancing, or let me say, the balance is still looking like temperature is increasing, is because it's as if as we try to remove this greenhouse gas from the atmosphere, we are still emitting some. As we are removing it from one part, we are emitting some from one part. As some countries are trying to commit to this, some other countries they keep increasing their emission. I mean, you see someone like Donald Trump withdrawing from Paris Agreement. China to today is set to limit their emission. And these two countries are like the two largest economies. They're like arguably the two most industrialized in the world. So those are the issues. So even if we want things to play out naturally and we want to see changes, from our own part as human, what are we doing that is not even making these changes necessary? So those are the issues. So would we have seen changes? Yes. I'm very just put one way to prove this is if you plant, if you go to a greenhouse or you go to a garden where you just plant plants, do you notice the change in that environment? Take note of it. But when you also have those plants in, let's say, a city, do you feel those changes as much? Definitely not, because there are a lot of humans there, there are a lot of activities going on there. So those are the issues.
Yes, thank you so much, Mr. Segun, for sharing your thoughts. That was really helpful. That has been an insightful section. I don't know if anybody have any further question. So yeah, we really appreciate you for taking time out of your busy schedule for this event. We appreciate everyone that joined as well. I hope you've learned one or two things from the session, and I hope we will be able to put this into our communication with others to enlighten them as well about this. So in summary, we've discovered that desert dust carries iron, and this iron technically serves as fuel for the ocean life, in terms of the phytoplankton, which then helps to produce oxygen that we all humans need for survival. So such a powerful, invisible connection that we've learned today. We really appreciate you all for joining. And that's where we're going to draw the curtain for today. And next month as well, we have another series with another interesting topic. So I would encourage you all to join as well for the session. So thank you everybody for your time. We really appreciate it. If you have any question, please feel free to pop it in the chat. If not, you could mute your mic as well and say your question. So I will just wait for a couple of minutes if anybody have any question before we close the session. Okay. Yeah, thank you all for joining, and that is where we are going to put the curtain for today. We really appreciate you for your time, and I hope you find this session insightful as well. Thank you all.
Thank you, sir.
Bye, everybody.